Yes.
Mm. Find the final image of object O after two reflections. Assuming first reflection is from M1. So we'll find the first reflection because of M1 first. From M1. And what is the object distance now? Minus 30. And focal length, which is minus 20. And image distance, which is equal to UF by U minus F. How much this value will come? Minus 60 centimeters now. Now, so this minus 60 from where you tell me now here? From the pole of the mirror. यहाँ से? And we need to wait. So this direction and this direction is positive direction now. Tell me
Yes.
now here. So we need to move the minus 60 means the opposite to incident ray we need to move now. So this is the 50 and then this will be a 60 might be. So we can call this is the first image. And I can say this distance is how much now? 10 centimeters. Now this I1, which is the image of the first mirror, is the object for the M2 now. And where the M2 will be formed now? Final image of M2. It should be formed somewhere here, I can say now. So this is, I can say now, I2. And this distance is how much? 10 centimeters. Okay.
Yes.
Now from this, what we can say now here, the final image is where it is located. Final image is where now here? 10 centimeters. Right side or left side? 10
Right side.
centimeters. Right, right of M2, or we can write it as a final image. Final image is where? 40 centimeters. 40 centimeters left of M1, isn't it? Okay.
Yes, sir.
Yeah. Say the next one. Here they given the two mirrors given. One is a convex, the other one is a concave. And here is an object. And we are calling this as M2 and this is M1. And this focal length, which is 20 centimeters, and this focal length is 10 centimeters. And this distance is 30 centimeters. And this is 50 centimeters. Now try it. Find the final image of object after two reflections. Assuming first reflection is from M1.
But V1 will be infinity.
What?
I got one in infinity.
Infinity.
Yes, sir.
So fine. So here, see the M1 now here. This is the convex or concave?
Convex.
This is the convex now. So here, and focal length, which is equal to plus 20. And
Sir, sir, it's base 10 and not plus 10.
Yeah, so U is how much? Minus 20 na? So V is equal to UF by U minus F, and which is equal to minus 20 into 20 by minus 20 minus 20. So how much this value? Minus 20 into 20. So this value minus 40. So the 22s, which will come to be plus 10. Plus 10 centimeters from where? Concave. So from the pole of the M1 now. So from here, plus 10. So this is the incident ray direction now.
Yes.
And this direction is positive, right? So from here, poles onwards, we need to move 10 centimeters. Which direction we need to move now? Left side or right side?
Right side.
Right side. So here is an object, image is formed. This is the first image. And so this distance is how much? 10 centimeters. Right. Now this image is the object for the M2 now. Now let's talk about the M2 mirror. M2 is a concave, and
Yes,
you
sir.
can see now M2 concave. So object distance is how much? 60. Object distance is how
Yes.
much? 60. Yes or no? Plus
Yes, sir.
60 or minus 60? Object
Sir,
distance.
minus.
Huh? And now so here, so look at now here, where is the actual object is there?
30 centimeters from the
Yes, this is
mirror.
the object now here. So this means the light ray has to come like this now here.
Yes, sir.
Light ray will come like this. Now here this direction, which will be a positive now.
Yes, sir.
Yes, positive or negative now here. UV is a for this mirror. And this is the positive direction. And we need to
Yes, sir.
start from pole onwards. We need to start now here onwards. We are moving. Which direction we are moving now? Opposite direction. So that is minus 60. Okay.
Yes, sir.
Now tell me now focal length is how much? Minus 10. Now find the V value how much now?
Minus 12.
Minus 12 now. So that is UF by, that is U minus F, which will come to be a minus 12 centimeters. Minus 12 from where? From
From
which?
the concave M2.
From M2, left side or right side?
Left side.
No, which left side is a positive or negative?
Oh, yes, sir. Right, sir.
So from here onwards, we need to move 12 centimeters. 12 centimeters. So means somewhere maybe here now. This is I2, right? And this distance is 12 centimeters. Okay.
Yes, sir.
Now you tell me now here how we can write now here. The final image is, where you tell me now here, final image. Image is at 12 centimeters left of, right of M2. Or we can write as final image is at how much distance? Total is 50. So this value 38 na?
Yes, sir.
Yes, 38 centimeters left of M1. Right.
Yes, sir.
Next one. An object is placed at x1 from the focus. Okay. And the image is formed at distance x2 from the focus. Find the focal length of the concave mirror. Hmm. Generally, they used to give the distances from where. So pole onwards we need to measure. But the distance they given from where now? Focus they given. Right.
Yes, sir.
Then what we can do here? Now let us say here we have this is the focus. And if I consider here is my some object is there. And we are assuming is somewhere we have the image is there. We are just assuming. Okay. Here the image. Now they given the distance of object from where they given now. So this object distance, this distance they given as a x1, and this distance they given as a x2, right? And so basically we need to measure the distances from pole onwards. We need to measure, right? So tell me now here what is the object distance? Object distance. Yeah, from here to here, this is nothing but focal length only, na? This is a
Yes.
focal length. So what I can say now, object distance, which will be equal to from the pole onwards, f plus x1, I can say, isn't
Yes.
it? So that is minus negative, na? And v is equal to what? Tell me now. This is also minus of f plus x2, I can write. And so concave, so that is focal length, which is always negative only. So use it now. Now try simplify it now. So that is 1 by f is equal to what? Tell me now. 1 by u plus 1 by v. So this is minus 1 by f, which is equal to minus 1 by f plus x1 minus 1 by f plus x2. Minus cancel, so that is 1 by f, which is equal to LCM. f plus x1 into f plus x2 into will commit as what will be now? Yes, 2f plus x1 plus x2 and cross multiply. So will commit as multiply this is if you yes f into that is f square plus f into x1 f into x2 plus x1 into x2 which is equal to 2f square plus f into x1 plus f into x2. Check for cancellations. So this is fx1, fx2 will get cancelled. F squared to f squared. So we'll come it as x1 into x2, which is equal to f squared. So that means focal length f is equal to square root of x1 into x2. Okay. Hmm? This is the focal length of the concave mirror.
Yes.
Yeah, this is one of standard formula. And this formula which is called as the Newton's formula. The name which is called it as the Newton's formula. If they given the distances, x1, x2 are the distances from the focus. x1, x2 are the distance from the focus. Then focal length is given as square root of x1 into x2. Where this is this formula which is called it as a Newton's formula. Okay.
Yes.
Hmm. So understood this concept now here. So single mirror we have seen plane. So two mirror combinations also we have seen. Right. Now we'll move to the next one, velocities. And we'll talk about the velocities in spherical mirrors. Mm. Here the two cases we are going to see now here. So first case we assume that object lies on the principal axis and it is moving parallel to principal axis. So let us say here, and these relations are applicable for both convex and concave. Here is an object is there. Now assuming that this object which is lies on the principal axis and which is moves parallel to principal axis like this with a velocity v0. V0 is the velocity of the object. V0 is the velocity of the object. Okay. Now here, focal length of the mirror is here. And if you see carefully, focal length of a mirror remains constant always. Now the mirror's formula we have that is 1 by f is equal to 1 by u plus 1 by v. Now I'm differentiating this equation with respect to time. Differentiate with respect to time. With respect to t. So differentiation f will be at 0 now, which is equal to minus 1 by u square into du by dt. minus 1 by v square into dv by dt. Okay. U is the object distance. Rate of change of object distance is called as a object velocity. V is the image distance. Rate of change of image distance is called as image velocity. Okay, so from this we can write as 1 by v square equal to dv by dt, and which is equal to minus of 1 by u square into du by dt. Okay, now I am writing it as 1 by v square, which is equal to, so image velocity I am writing it as the image velocity with respect to mirror. This is in parallel. That's why we are writing a parallel symbol. And that is equal to minus 1 by u square into, we can say this is the velocity of the object with respect to mirror in parallel direction. Then we can write finally velocity of image with respect to mirror in parallel, which is equal to minus of v square by u square into velocity of object with respect to mirror in parallel. Okay, so this is the velocity of image with respect to mirror in parallel, which is equal to minus of, what, tell me now, v by u whole square into velocity of object with respect to mirror in parallel. So this is the velocity of image with respect to mirror in parallel direction. Here the object is moving parallel to principal axis. Right?
Yes.
In this case, parallel case, this relation we use. Next, and perpendicular. You have studied the lenses also.
Yes.
Lenses also there now. Okay. And whatever the formulas we are going seeing in the mirrors, the similar kind of problems you will find in the lenses also. Okay.
Yes.
And you have studied about the refraction also.
Yes.
Refraction, TIR, total internal reflection. Studied?
No.
TIR not studied. Only refraction, total internal reflection not studied. Optical fiber applications not studied.
No.
Okay.
Only basic.
Okay. Prism.
No, sir, we don't have one.
Okay. Prism also you don't have. So after refraction, what topic
I
was?
think prism.
Huh?
So I think prism we have in like human eyes. We have prism in human eye.
Okay. Prism separately not studied. Okay. After refraction, what you studied?
So after refraction we had lenses, and after lenses new chapter is human eyes.
Okay. New human eye. Fine. Okay. Fine. Yeah. So then this order will come it as prism, and thereafter we'll see the lenses. We'll see this thing. These are the topics. And thereafter last we have human eye. Now see this thing. Object is moving perpendicular to principal axis now. Now, let us consider here we have the object. Now this object which is moving perpendicular to principal axis means like this. Object is moving perpendicular to principal axis. Now in this case, if we see carefully, and this is what you tell me now, object. Object distance is u now, and this is the focal length. And if you observe here, the focal length is constant now. For the mirror, focal length is always constant. And what about the object distance? Constant or variable? Constant or variable. So here initially object here, this is u. The object is here. Now again we'll see this distance only we'll see or not.
Yes.
Still object distance is constant only, isn't it? Object
Yes.
distance is constant. Object distance constant. What about the image distance? So we have the formula 1 by f is equal to 1 by u plus 1 by v. F constant, u constant, then obviously v also constant only na.
Yes.
And but what changes we need to see here? Here what changes here? Because of the spherical nature, spherical curveness, because of the curveness, magnification changes. What changes? Magnification changes. And what is the magnification? M is a, all these parameters are constant, so we should don't use them. So, but the magnification changes. If it is a plane, so magnification is also constant. But here, because of the curveness of the mirror, so with the object is here, when the object here, then it will be at the curved location now. Because of the curveness, magnification changes. And what the magnification formula? That is given as height of image by height of object. So that is hi, and which is equal to what element of m into h naught. Okay. Now we are
Yes.
differentiating both sides now here. So dhi by dt, and which is equal to m changes, height of image also changes. We need to apply the u into v rule. Okay. First we have taken m constant, so the derivative is for h naught. Okay. Thereafter, h naught is constant and derivative is for m, dm by dt. Okay.
Sir, I have one doubt.
Mm.
Sir, m is also equal to minus v by u, no, sir.
M is
So
also.
technically constant.
No, but here m is basic formula is height of image by height of object, na. So
Yes, sir,
object
but
locations are same. Locations are same, sizes are different. Location
okay, sir.
of image is same, but the size of the image is different. Okay,
Okay, sir.
that's why we need to apply the m as a variable quantity. Right. And you can see now here, and what is the dhi by dt? This is dhi by dt. This is called it as what, tell me now? Velocity of image with respect to mirror in perpendicular direction. Okay. And dh naught by dt, and which is equal to velocity of object with respect to mirror in perpendicular direction. Okay. Now we can substitute
Yes.
these relations here. then we can write as what terminal velocity of image with respect to mirror in perpendicular, which is equal to m into, and this is dh naught. So this is nothing but what, tell me now? dh naught, velocity of object with respect to mirror. Velocity of object with respect to mirror in perpendicular direction plus h naught into dm by dt. H naught into dm by dt. Okay.
Yes.
Yes. This is the velocity in case of a, if the object is moving perpendicular to the principal axis. And where this h naught is, what, tell me now? H naught is called it as what, tell me? It is the height of object. Height of object from the principal axis. If h naught value 0, then what happen? If some cases object lies on the principal axis. If the object lies on the principal axis, if h naught 0, if the point object lies on principal axis, if it lies on principal axis, then h naught value 0. If the h naught value 0, then what happened to this formula now? Then this formula modified to velocity of image with respect to mirror in perpendicular, which is equal to m into velocity of object with respect to mirror in perpendicular. So the second term will become completely 0. Okay. Done?
1 minute.
Hmm.
That's
Now let's see some problems now. V naught they given as a 2 centimeters per second. Find the velocity of image.
Why can you explain?
Hmm. Yes, now first find the image distance. Find the image distance.
Then minus 40 centimeters.
Yeah, so we got minus 40 centimeters now. That is V. So this is minus 40 centimeters. Yeah, you can tell me now here what we need to get. Hmm. So first we need to see this thing here. Object is moving, and how the object is moving now? Parallel to principal axis, perpendicular to principal axis.
Parallel.
Parallel. So that means we have this is V parallel now. That is, we can say now velocity of object and with respect to mirror in parallel, and which is given as what, tell me now, that is 2 centimeters per second, right? Now, so then parallel case velocity formula, tell me, then what is the velocity of image with respect to mirror image in parallel direction?
Minus 2 centimeters per second.
Yes, so which will be equal to this is velocity of object we have, this velocity of image we need to find now. So that's be what the formula we have seen, minus of v by u whole square into velocity of object with respect to mirror in parallel. So we can find out this value, this minus of v value how much? V value minus 40, u value how much? U value also minus 40 only, na? Whole
Yes, sir.
square, which is equal to what, tell me now, 2. So finally
Yes.
we'll get the velocity of image with respect to the mirror in parallel, which will be equal to minus 2 centimeters per second. Okay.
Yes, sir.
Yes, and there is no perpendicular velocity, right? So finally, so velocity of image, what I can say now simply, which will be equal to minus 2 centimeters per second. There is no perpendicular velocity now. And what the v perpendicular case, if we have perpendicular velocity, we need to proceed it. And what the v perpendicular? So velocity of object with respect to mirror in perpendicular direction. How much is value? 0. And what is the perpendicular velocity, image velocity formula? Velocity of image with respect to mirror in perpendicular, which is equal to, tell me now. So that formula which we have seen now, which is equal to m into velocity of object with respect to mirror in perpendicular plus what, tell me now, I think space not sufficient. So plus we should write as what, tell me now here, h naught into dm by dt. Okay, so this is perpendicular, this term is 0. This term is 0, and then h naught. What is the h naught is height of the object from principal axis. Height of the object from principal axis, which will be 0 on, it lies on the principal axis. So here h naught value 0 now. So that's why this term is also become 0. So finally velocity of image with respect to mirror in perpendicular. How much this value, tell me now? 0. Okay.
Yes, sir.
So finally, So basically final velocity of image means what, tell me? It is always a combination of velocity of image with a parallel component as well as a perpendicular component. Both will come. Parallel as well as perpendicular. The perpendicular is 0. So that's why final velocity of image will come to be a what, tell me now? Only parallel component only. There is no perpendicular component now. Perpendicular component of velocity is 0. Okay.
Yes.
Hmm. Take this next problem. Here is the object. Now the object is moving like this with a velocity v0 is equal to 2 centimeters per second. And the focal length is a 20 centimeters and this distance is a 30 centimeters. Hmm. Tell me now, in this case, how this object is moving?
Perpendicular.
Perpendicular. So first find the image distance.
So that is the answer, 4 centimeter per second.
Yeah, 4 centimeters per second. Yes. Minus 4.
Yes.
Yeah, so U value is minus 30 centimeters and this focal length which is equal to minus 20. And what is the V value, tell me now? Image distance is how much?
60.
Yeah, so that is minus 60. And so here, and we are finding, so they given the velocity. So velocity of object with respect to mirror in parallel is how much? Parallel. How much is velocity?
2 into minus.
See this thing, parallel velocity 0 now. There is no object is being perpendicular only. There is no parallel velocity.
Yes.
So that's why so and velocity of image with respect to mirror in parallel. What is the formula for this one? Which is equal to minus of v by u whole square into velocity of object with respect to mirror in parallel. Since this term is 0 na, so that's why velocity of image with respect to mirror in parallel is also 0. Okay. Next, we need to find the perpendicular velocity. And here, where is the object lies now here? Object initially lies on the principal axis now. That's why h naught value how much now? 0. Now velocity of object with respect to mirror in perpendicular. How much you tell me? Which is 2 centimeters per second. Now velocity of image with respect to mirror in perpendicular, which is equal to, tell me now, which is equal to m into, so this is velocity of object with respect to mirror in perpendicular plus h naught into, this is dm by dt, right? H naught value 0. So from this we'll get velocity of image with respect to mirror in perpendicular, which is equal to m value how much? M is equal to minus v by u. How much this value? V value? V value minus 16, huh? So this value minus 60 by minus 30 into this one, which is equal to 2. So we'll commit as what, tell me now? Which is equal to minus 4 centimeters per second. Here there is no parallel velocity, right? So velocity of image with respect to mirror, finally we can write as velocity of image with respect to mirror in parallel plus velocity of image with respect to mirror in perpendicular, and which will come to be a parallel component is 0, only we have perpendicular component only, centimeters per second. This is the final velocity of image with respect to mirror. Okay.
Yes, sir.
And this is the way we need to solve these problems. So if they given parallel velocity, only the parallel components and parallel, but basically velocity of image means which is the combination of parallel as well as perpendicular. Now take this problem. Hmm. So in this case, it will have a parallel as well as perpendicular components also, isn't it? We resolve the velocity into two components now.
Yes, sir.
Yeah. So in this case, both velocities we need to consider. If I consider this is x-axis, y-axis. Now, so first find the image distance, object distance, which is minus 30 centimeters, and focal length, this is minus 20 centimeters, and image distance, how much? How much the image distance?
Minus 60 centimeter.
So this is minus 60 centimeters. Okay, fine. Next, now we have see the velocities now here. The component of velocities, you tell me now. Now this velocity of object, in parallel, you tell me now here. Velocity of object, which will be given as, we can resolve into components now. This is 5 into, and this component is a cos, isn't it? Cos 37 into I cap plus 5 into sine 37 into j cap. Now tell me.
Yes, sir.
Now, so this means cos 37 value how much? That is 4 by 5. Remember this thing helpful. And that is sine 37 value, that is 3 by 5. So that means velocity of object with respect to mirror, which will come cos 37, will come it as 4i cap plus 3j cap. Right. Now we need to separate this into as a parallel and perpendicular components. Tell me now, what is the velocity of object with respect to mirror in parallel? Parallel means which axis? Parallel to principal axis, x-axis. So that's why 4 into I cap. Velocity of object with respect to mirror in perpendicular, which will be equal to 3j cap. Is it fine?
Yes, sir.
Next. Now we need to apply the formulas. Yeah, we'll find the magnification also. M value here, how much will come? Minus V by U will come. How much now? 2 or minus 2? Minus 2 now?
Yes,
So you can tell me now here, velocity of image with respect to mirror in parallel, which is equal to minus of V by U whole square into velocity of object with respect to mirror in parallel.
yes,
Now simplify it. So how much will come velocity of object with respect to mirror in parallel, which is equal to what? Tell me now. Minus of, so this value V by U, this whole square, 2 square na 4. 4 into parallel component of velocity is 4 I cap. So this will come to minus 16 I cap. Perpendicular component is how much? And velocity of image with respect to mirror in perpendicular direction, which is equal to, that is m into velocity of object with respect to mirror in perpendicular plus h naught into dm by dt na. H naught is 0. Since the object lies on principal axis na, h naught value 0. So finally will come to be what? Tell me now, velocity of object image with respect to mirror in perpendicular, which is equal to m value is a minus 2 and this value perpendicular velocity is a 3j. So will come it as minus 6j. So finally we can write velocity of image with respect to mirror, which will be equal to minus 16 I cap, minus 6j cap. Okay.
Yes.
Mm. Done.
Yes, sir.
Mm. Understood this thing. So how you need to solve the velocity for problems.
Yes.
Mm. Okay, fine. Okay. I'll share the worksheet and try to solve those questions for the next class.
Okay, sir.
Okay, fine. That's it for today. We'll meet in the next class. We'll meet.
Thank you so much.
Okay then.